Hey everybody, welcome to another interesting session where we are going to discuss another popular algorithm typically used in the classification, which as you see right here is logistic regression. So a lot of people basically are curious about understanding what's the underlying mechanics of this algorithm, right? Because it's commonly used in classification and it's a supervised learning algorithm. So let's spend some time discussing the underlying mechanics behind this algorithm and how does it basically work, right? So this is a class of classification algorithms, and it also comes under the category of supervised algorithms. Why? Because you feed it with a labeled data set, right? So typically, we use this for binary classification. So what is binary classification? Where the output is categorized in two classes. Either it's going to be a yes or a no. It's going to be, say, disease or no disease. It's going to be a default or a no default, right? Suppose you're talking of customer churn, there's going to be a churn or a no churn, right? So let's take a typical example where we try to apply logistic regression. Let's say we have a data set that looks like this, right? Let's say this is your credit card data set, and you have typically columns like, say, the age of the customer, the loan amount of the customer, then the duration of the loan in years, and then default history, whether the customer has defaulted in the past or not, right? And this is the final result column, whether it's a default, a yes, or a no. So this is your historical data where you have, say, age might be, say, 25, the loan amount might be, say, $100,000. This is in thousands, okay? So $100,000, duration might be, say, 10 years, default is to previous default is no, okay? And so default, this person has not defaulted. So the result observed for this person is a no, this person has not defaulted. Okay, similarly, you have like say 35, like say $20,000, $200,000, right? And then duration might be 15, and then default might be a yes. And this person is yes. Similarly, you have something and say 13, and then this might be again no, but this time it might be a yes, so on and so forth. You have many such values, and then there are certain yeses. So basically, this column has a lot of no's and yeses over here, right? Let's say we convert this categorical to numerical, like say no is a 0 and yes is a 1. So it has zeros and ones, right? Similarly, this one, right? So in your linear regression, what you would typically do is you would regard these columns as the variables like say x1, x2, x3, and x4. And this is your y, right? Your prediction. This is what you're trying to predict, right? So linear regression would typically try to find out coefficients for this x1, x2, x3, x4 such that the y would be the most likely prediction, right? So it's like say w1 x1 plus w2 x2 plus w3 x3 plus w4 x4 equals your y, right? This one. Okay, but here there's a problem here because this is the equation of, say, a straight line, and this is going to predict something called as a continuous value, right? This continuous value can be anything from minus infinity to plus infinity. But what you're trying to predict here is categories like 0, 1, 1, 0. So this itself is not good work. You need to somehow convert this to a categorical variable, right? Something which gives you a number that signifies a category. So what you do here is you convert this to a probabilistic output, something between 0 and 1, and you create a threshold. Like say if your value is greater than 0.5, then it falls under the category of 1. If it's less than 0.5, it falls under the category of 0. That's something which you plan for, okay? So the way to convert that is using something called as a sigmoid function. What is a sigmoid function? This equation is like sigmoid equals 1 divided by 1 plus e raised to minus x. Okay, so whatever the value of x is going to convert that to a value between 0 and 1. So if x is minus infinity, right? X tends to minus infinity, the value of sigma, the value of this function is going to be 0. And if x is plus infinity, then the value is going to be 1. If you can put these values assigned here, you'll find this for yourself, right? So how do you derive the value for this sigmoid function? It's pretty simple. Now here comes the underlying assumption for logistic regression. What is the assumption here? The assumption is that this straight line, right, which we just spoke about, W1 x plus W2 x2 plus W3 x3 plus W4 x4, this straight line basically represents the log of the odds. What do you mean by the odds? Basically, in probability, the odds means the probability of an event happening, which is P, divided by the probability of the event not happening, that is 1 minus P, okay? So suppose the prediction is a default, right, with probability P, then the probability of non-default is 1 minus P. So this probability, this ratio of P to 1 minus P, the log of that ratio is basically the straight line. W1 x1 plus W2 x2 plus W3 x3 plus W4 x4, okay? Let's represent this straight line by Z, okay? Right, so rewriting this, it becomes log of P by 1 minus P equals Z. Now, if we take an exponential on both the sides, this becomes P by 1 minus P equals e raised to Z, okay? So if you rearrange this, this becomes P equals 1 minus P into e raised to Z. This implies P equals e raised to Z minus P e raised to Z. Okay. So this equals P So let's take this here. P into bracket 1 plus e raised to Z equals e raised to Z. This means P equals e raised to Z divided by 1 plus e raised to Z. Now, if you divide the numerator and denominator both by e raised to Z, what you get is, final equation is P equals 1 divided by 1 plus e raised to minus Z, right? This is the final equation of a sigmoid function. So this means that this straight line, which is given by Z, is related to the probability of a category in using this equation, right? So you first compute the value of the straight line using the coefficients predicted by the predicted by logistic regression, and then put that value in the sigmoid function, which gives you the probabilities. Now, this probability P might be something like, say, 0.73. So 0.73, if it's greater than 0.5, the threshold, then you can categorize this into, say, default, which is 1, right? And then right? So value of yes is 1. And then if this comes out, we say something like 0.32, which is less than 0.5. You can categorize this as non-default. Clear? So the final question is, how does the model determine the values of these coefficients, right? W1, W2, W3, W4, so on and so forth. So they are determined by a process called as the maximum likelihood. What does this mean, likelihood? Like mathematically, what's happening is, if you take this data set, like say a sample data set, let's say you have your x1, x2, x3, x4, and then your y, x1, x2, x3, x4, and then your y, right? Whereas the coefficient is like say W1, W2, W3, W4, right? Suppose now for this first row, the value of y was actual value of y was 1. Let's say it was for the second row, the actual value of y was a 0. The third row, the value of y was again a 0. For the fourth row, the value of y was again a 1. So on and so forth, right? So now what the model is going to do is while training, it's going to compute this weighted product, W1 into X1 plus W2 into X2, whatever the value of X1, X2, X3, X4 is at this row. And then whatever the value comes out to be the Z value, which is W1, X1 plus W2, X2, whatever the value is, it's going to transform this is using the sigmoid, like 1 by 1 plus e raised to minus Z, and whatever the probability P it gets as a probabilistic value between 0 and 1. The next thing it's going to do is if the actual for this was a 1, it's going to retain the value of P. But then if the actual for this was a 0, it's going to take the value as 1 minus P, right? Because 0 means it's falling on the other side of the class, right? Similarly, even here it's going to take 1 minus P. Here it's going to take P. Here 1 minus P, so on and so forth. And at the end, it's going to compute this entire product, like P into 1 minus P into 1 minus P into P into 1 minus P, like P into 1 minus P into 1 minus P into P into 1 minus P, whatever, until how as many rows we have. Like suppose we have say 100 rows, so 100 such items in the product. And then this product basically has to be the maximum because this basically shows the likelihood, right? If you multiply all these values, P into 1 minus P until the end, it shows the total likelihood of this event to happen. It basically says that what is the likelihood, right? Given the fact that you see such an occurrence, what is the likelihood that these might be the coefficients? That's basically the maximum likelihood. Okay. So it tries to find out the best values of W1, W2, W3, and W4, which will maximize this product. Oh, okay, that's called as the maximum likelihood. So in this way, logistic regression works end to end, all right? I hope this is clear to everyone. If you have any questions, please feel free to write in the comment box at the bottom. And if you want me to make a video on any other algorithm or any other topic in this domain, then please feel free to comment accordingly, all right? Until then, see you in another video. Take care. Bye-bye. If you like this video, please press the like button. For more such videos, subscribe to the channel. If you have suggestions for a new topic and would want to see a video made on that topic, please feel free to comment in the comment section below. Thanks for watching the video and see you in another video. Bye bye.